This problem gives you a little bit of a sense of how we want to try to organize our data when we're looking at a problem with cash flows that occur across time. So part of what you're going to see here is just the general setup of what we refer to as a timeline, which relates the idea of the particular time period, today is always time zero, and the cash flows and when they're going to occur. Now we're going to try to demonstrate the use of that and where that fits in by handling a little problem here. Suppose you're beginning your first year of college and your great aunt Matilda has offered to reward you for your success in school by giving you $5,000 per year for each of the next 4 years that you successfully complete a year of college work. Now you'd have preferred to have had the money today in order to purchase a car. So before borrowing money at 8% interest to purchase this vehicle, you just want to determine what's the value today of Aunt Matilda's gift. So that way you can go out and borrow the money, pay for your new car. Okay, obviously a previously owned car, but a car nonetheless. Now, to be able to deal with this, what we have is we want to ask the question, although it's going to be a year from now in which you expect to receive $5,000, at 8% interest, the question is, what is it worth today? Likewise, $5,000 2 years from now, what is it worth today? And so on here for each of the 4 years. When we add those things together, it's going to give us a feel for what it is we'd be able to borrow today. Now, the first thing we're going to do is we're going to put in a present value interest factor. This is the discount factor that we're going to be able to use. And it's equal to 1 divided by 1 plus whatever your interest rate is. Okay? And then we will raise that to the power of the number of periods. So this is at time 1, so we'll raise it to a power 1, and so on for each subsequent year. And it will show us how to discount things back. Now, I wanted this statement in such a way that I could copy this to each of the succeeding columns. And because it's all fixed on this interest rate of 8%, when I go column to column in order to hold that in place, I'll put a dollar sign in front of the C of the C6, so it always recognizes that it's in column C, the information that I want. Now, I get a factor of 0.9259. What that means is a dollar 1 year from now is worth 92.59 cents at time 0. Now, watch what happens when I copy and paste this in place for the subsequent years. What I find is a dollar 2 years from now at an 8% interest is worth 85.73 cents today. 3 years from now, a dollar is worth 79.38 cents today. 4 years from now, a dollar is worth 73.5 cents today. Now, if I simply multiply each of these through, in other words, I take, here's my $5,000 1 year from now, multiplied by the 0.9259, it says that, okay, that's worth $4,629.63 today. The 5,000 2 years from now, when multiplied by the factor, tells me it's worth 4,286.69 cents today. The 5,000 3 years from now, when multiplied by its discount factor, is worth $3,969.16 today. And finally, the 5,000 4 years from now, when multiplied by its discount factor, is worth $3,675.15 today. Now, if I sum all of these up, I'll go to my auto sum and add those 4 items up. It says $16,560.63 today, which means if I've got this promise to receive $5,000 in each of the next 4 years, today it has a value of $16,560.63. So I can go ahead and find that previously owned car of this value, and it would be fully paid for. If I borrow the money at an 8% interest rate from a bank, what I'd have is an opportunity to exactly pay off my $5,000 amount each and every year.